Today's notes are factoring by grouping 1 3s and 3 1s. We've done grouping by 2 2s, but today we're going to elaborate on different ways of grouping and focus on 1 3 grouping and 3 1 grouping. So to start off, we're going to do 1 3 grouping. And what we mean by 1 3 grouping, right here, okay, is that we're going to look for 4 terms, okay, but within those 4 terms, the first 3 have to be a perfect square trinomial. Okay, and what I mean by that is something like x plus 2 times x plus 2. When you have the same binomial squared and you FOIL that out, this is a perfect square trinomial. And that's true of if I did, x minus 3 times x minus 3, x squared minus 6x plus 9 is a perfect square trinomial. So what we're looking for is a perfect square trinomial for the first 3 terms. And then the last term is going to be a perfect square, but what we're going to do is look for what sticks out, and I'll explain what that means in a minute. So these things have to be initially satisfied in order for us to factor a 4-term polynomial by using 1 3 grouping. So let's go ahead and look at number 1. All right, if I look, for the first 3 terms, I have m's, mn, and n. So those 3 kind of look together. And if I look at this closely, that indeed is going to be a perfect square trinomial, and I'll tell you that in a minute. Let's just make sure over here, is there another term that's a perfect square? Well, 25 is a perfect square and so is x squared. And does it stick out? And what I mean by stick out is x squared is a totally different variable than m and n. So this kind of sticks out by itself, so I'm going to group the first 3 and then leave the last one on its own. And this is what we're going to do. We're going to take the first 3 and we're going to factor that. Now, in the beginning, when I factor it, I can kind of just factor it as if I were to give you a problem in general, how to factor this. What would multiply to give me, m squared plus 6mn plus 9n squared, right? And again, if there's a coefficient of 1 out there, I can say what multiplies to give me 9 and adds to give me 6. And I know those are going to be 3 and 3. The difference is when I go to do this m plus 3 and m plus 3, I need to make my parentheses a little bit bigger, but I also have this n here. So when I take how do I get 9n squared, I'm going to need a 3n and a 3n. I'm just going to bring down the negative 25x squared. If you look closely, what's going to happen with this perfect square trinomial is the 2 binomials when you factor will be the same, and that's one of the clues that we can factor this by a 1 3. So I'm going to clean that up and say, hey, this is really m plus 3n quantity squared minus 25x squared. Okay, now here's the part that looks weird, but once you understand it, it's going to make things run much more smoothly. I have 2 terms here. I have a term here, and I have a term here, and I have a difference. Believe it or not, this is a difference of squares. It's a subtraction, it's a difference of 2 perfect squares. And when I have a difference of squares, I make parentheses, right? I take the square root of each term and make 1 plus 1 minus. So if I had, x squared minus 16, you do x and 4, and then x and 4, you make one of a plus and one of a minus. Okay, well, you're going to do the same thing here, okay? It just looks different, but it really is a difference of squares. If I look at this first term, m plus 3n quantity squared, the square root of that would just be one of them. So if I put m plus 3n on the left side and m plus 3n, that's the square root. What's the square root of 25x squared? Well, it's going to be 5x and 5x. And just like an easier difference of squares, you're going to make one of these a plus and one of these a minus. And that would be your final answer for factoring a 1 3. Okay, let's look at number 2 and do the same sort of thing. I look initially, it's 4 terms. If you were to group 2 2, let's just kind of talk about that. I would not be able to group 2 2 and get matching stuff because I have x's and xy's here, I have y's and p's here. So you cannot do 2 2 grouping. You've got to think about that too. So you don't forget about all the other factoring techniques we taught you. So if I look at this closely, I have 4 terms. And this looks like x squared, xy, and y squared. So those look like they go together, and this p squared looks like it sticks out. So let me try, I just realized what I did. These are 3 1s. I'm losing my mind. Sorry. Change this to 3 1. I'm going to change your notes. This is just, should be 3 1. I'm losing it. So 3 1s. Sorry, these are 3 1s, not 1 3s. We'll get there in a minute because I have the first 3 together and then the one that sticks out. And the first 3 together and the one that sticks out. So I'll change that on your note so it will say 3 1 when you see it. So look at the first three terms. These kind of look like they could go together, and let's see if that's a perfect square trinomial, meaning can I get something multiplied by itself to give me the trinomial? Well, let's try. X times x gives me x squared, and I know to get 4y squared I would need a 2y and a 2y. To get the plus 4xy, if I multiplied my outers and my inners, x plus 2y, 2xy and 2xy, that would work if these are both positive, which indeed confirms that that's a perfect square trinomial. Now, don't forget I have this minus 100p squared here. I got to bring that down. So I have x plus 2y quantity squared minus 100p squared. Here's where we're at our difference of perfect squares. So I'm going to make my parentheses and say, okay, I'm going to take the square root of each term. Well, x plus 2y quantity squared, the square root of that would just be one of those. So this, x plus 2y, the square root of 100p squared would be 10p and 10p. So I make one a plus and one a minus. So that's another 3-1 factoring. All right, look at number 3. I look at 3, 1, and it looks like, yes, these three are together, meaning I've got y's and z's, and this a stands out. So it looks like it's going to be a 3, 1. The only problem is when I do a perfect square trinomial, I really want my first term and my last term to be perfect squares, okay? Kind of like the 9n squared and m squared, or the 4y squared and x squared. I really want this term that has double variables to be in the middle. So what you're going to have to do sometimes, and it's a little tricky, especially first starting this, but you're going to have to rewrite this. So what I mean by that is I'm going to leave z squared out front. I'm going to put the 12yz in the middle, and then put the 36y squared out last. So all I did was rearrange the first three. I'm going to leave the negative 49a squared. And now it does look like a 3, 1. This is going to be a perfect square trinomial. Now, if some of you want to skip ahead and say, hey, I know it's going to be a z, and I know to take the square root there, I need a 6y, and square it, you can do that. All right. Make sure you get your signs correct, though, meaning that if it's a plus and a plus, I'm going to have a plus here. If that does not work for you, I'm going to kind of erase this. You just go back to the other steps we did and say, okay, I'm going to factor this like normal. I'm going to say z plus 6y, and then I would need another z plus 6y. And so I'm going to have those things, and I'm going to square those. So whichever, if you can skip this step, that's great. If you can't, then that's fine. So work what you need to work with. All right, so let's go ahead and finish doing this one. So if it's a difference of squares, all right, I'm going to say, okay, I know I have this thing squared minus this thing squared. So the square root of z plus 6y squared is just z plus 6y. So I'm going to put that on the left side of each term. And then the square root of 49a is plus 7a and a minus 7a. Okay, try to do number 4 on your own. And it is going to be a 3, 1. Go ahead and look at it, try to factor it, and then press pause on the video and come back to it to check your answer. Okay, so number 4, if I group the first 3 together, and I'm looking for what would make this into a perfect square trinomial, or is this a perfect square trinomial? Well, to get 4w squared, I want to try 2w and 2w. And again, I don't want to try 4 and 1 because that's not going to make the same binomial squared. I'm looking for a number times itself to give me whatever term I have. Over here, I'm going to put 4t and 4t because 4 times 4 would give me 16, t times t was t squared. Now be a little careful here. If I look at this, sorry, that's not a d, t, that's a d. Let me change that. Oops. Erase that. Erase that. So let's put, sorry, it's d squared. I'm going to go back. Let's just start over. Okay, let's do this again. 2w come on, there we go, 2w, and then the square root of d squared is just d, so I have a plus and a minus, and then I'm going to bring down the negative 16t squared. I can rewrite, now wait a minute, I'm going to take a look at this more closely. So you look, wait a minute, I can't have a negative here because to get a positive d squared, I would need this to be a negative as well. And it would also need to be negative because when I did 2wd and 2wd, in order to get a negative 4wd, I need both of those to be negative. So I have to have the same binomial squared. So it was good that I kind of checked my work and said, wait a minute, it has to be 2w minus d quantity squared minus 16t squared. Now you have the difference of perfect squares. So I make two parentheses and say, okay, the square root is 2w minus d, 2w minus d, and then I have 4t. One of them's a plus, one of them's a minus. So that's how you factor your 3 ones. All right, then we're going to go to 1 3s. And so kind of yours will be fixed. This is a 1 3. The first term is the perfect square that sticks out, and the last 3 terms are the perfect square trinomial. A lot of this is going to be similar, but there's 2 steps that are really important in order to make sure you don't mess up the negative signs or the signs in general for your answer. So if I look here, I have 4 terms. I know it can't be necessarily a 2 2 because I have x's and y's over here and y's and z's. There's no way that I could get those 2 to match up. So if I go to if I look for kind of, or how do I figure out whether it's a 1 3 3 1? You need to figure out what sticks out and whether it's in the front or it's at the end of your polynomial. So if I look here, I have y's, yz's, and z's. This sticks out, this x squared, and that's in front. That one term sticks out in front. So I'm going to keep the one term out front, and I'm going to group the 3 terms together after it. So that's why we're calling this a 1 3. The issue is when I go to group those 3 terms, I've got this negative here. And I can't really factor a perfect square trinomial when I have a negative coefficient. So what you need to do first, right, make sure you do this on every single problem that you recognize as a 1 3, is first you need to pull out that negative. So what I mean by that is leave the x squared, leave the thing that sticks out by itself. I'm going to pull out a negative out of whatever is left over. So it's going to change to a positive y squared, a positive 2yz, and then a positive z squared. All right, so pull that negative out. Now, leave x squared, leave the negative. I want you to factor this just like we factored above. This should be a perfect square trinomial. All right, meaning, how do I get y? Well, I need to do y times y. How can I get z squared? It should be z times z. Would these, if I FOILed them out, get me y squared plus 2yz plus z squared? Well, yz and yz it would if both of these were positive. So this is really x squared minus y plus z quantity squared. So it's similar to the 3 ones because now you're at your difference of squares again. So here's my difference of squares. Here's my difference, here's a perfect square, here's a perfect square. So when I go to write this, I'm going to say, okay, my square root of x is x. Now, this is where this gets a little bit tricky. So this is the second issue kind of with 1 3s where it makes it a little more tricky. So the second part, I'm going to kind of put second, that you need to remember to do is when I do a 1 3, when I go to put my square root of y plus z and y plus z, if I just put in a plus and a minus, the plus is fine, but the negative, I'm really subtracting this quantity. So you need to make sure that when you do a 1 3, I would like you to put parentheses around the second term. Okay, when you have the plus within that polynomial, that trinomial, it's not going to change. But this minus is going to change the signs of what's in that binomial. So meaning my final answer, I'm going to leave x plus y plus z, but this is going to change to x minus y minus z. All right, so be very careful about the first step, pulling out the negative, and then the last step to distribute the negative. All right, let's look at number 2. It's 4 terms. I think about doing 2 2, but I have s and m and n. That's not going to work. I try to see if I have a perfect square, and is it in the beginning or is it at the end? So if I look, it looks like these 3 kind of can go together, and the s squared is what sticks out. All right, so what I'm going to do is if the s squared sticks out and it's in front, I know I'm doing a 1 3. So I'm going to make this a trinomial. I'm going to bring down my s squared. The first step, again, make sure you do this, is you've got to pull out that negative. Okay, you've got to do that. Don't skip that step. So that'd be m squared minus 2mn, plus n squared. Make sure you change the signs of the guys within the trinomial. So now, if I go to factor this as a perfect square trinomial, I'm going to say to get m squared, I could do m times n, m. To get n squared, I could do n times n. But be careful with your signs. In order to get a positive when I multiply, but a negative when I add, I'm going to have to do m minus n times another m minus n. So if I clean that up, I have s squared minus m minus n squared. Here's your difference of perfect squares. Okay, so I'm actually going to bracket these. Hopefully I can fit this, sorry. I'm going to bracket this. say the square root of s is s, the square root of m minus n in parentheses is m minus n and m minus n. I'm making one of them a plus, one of them a minus. The reason why I think it's nice to use brackets for the 1, 3 is to remind me that, hey, I can leave the first one alone, s plus m minus n, but here I have to distribute my negative, so it's s minus m plus n. Okay, so be really careful. Go ahead and try to do number 3. Kind of pause the video and do that on your own, and then come back and check your answer. All right, so let's see number 3. My stick out term, kind of what's on its own, is the c squared, and these look like I could group them. So let's do a 1, 3. In order to do the 1, 3, let's pull out the negative first. So I'm going to say negative, I'm going to change it to a positive 4f squared, a positive 12fg, and a positive 9g squared. Now, even though there's coefficients, don't make it any harder than it looks. Just factor this, knowing that you're looking for a perfect square trinomial, meaning that you're looking for the same thing in the binomial written twice. And the way for it to be the same is by saying what number times what number gives me 4f squared. Well, let me try 2f and 2f. What number times what number gives me 9g squared? Let's try 3g and 3g. And then to get your inners, right, your oobies, to get my 12, if I did 2 times 3, that would be 6fg, and another 6fg, that would give me 12 if these were positive. So I'm going to simplify that to c squared minus 2f plus 3g quantity squared. All right, I'm going to come over here. That is a difference of perfect squares. So what I'm going to do, and actually, sorry, let me start with the brackets just to kind of be consistent with what I was telling you guys. So I'm going to put brackets in for my 1, 3s. So put brackets and then brackets, because that will remind me to distribute my negative. I take the square root of c squared and get c and c. I take the square root of 2f plus 3g squared, and the square root of that is just one of them. Make 1 plus, 1 minus. So my last step is just to leave c plus 2, c plus 2f plus 3g, and then c minus, distribute the negative, 2f minus 3g. Okay, so make sure you guys understand these. If you need to replay it again, do so, and we will work on more examples of this in class.